So when you go to the Blackboard site here, and it's going to be in course content, you're going to have two links. And what do they say? Online course for March the 11th and online course for March the 13th, which would be Monday and Wednesday. Now there's nothing in here right now. But the way it's going to work is inside here is going to be an online lecture. In fact, it's just going to be a link to YouTube. And then there's going to be a quiz in there on the what? On the lecture. Okay. And this guy will pop up. It'll pop up at probably on midnight Sunday night. And then it's going to disappear at midnight Monday. So that gives you basically 24 hours to do what? Watch the lecture and take the quiz. And you're going to be responsible for it whether you do it or not. And then it'll disappear. And then the other lecture will pop up on Wednesday. Might not be Monday, Sunday midnight. It depends on when I can get it up there. But it should be there Sunday midnight. Yeah. It'll pop up on what? Wednesday, right? But you'll have all day to do what? To watch the lecture and do the quiz. Everybody okay? And then I'll be back on the next week. So any questions on that? So when we come back, we'll probably be in lab a lot. In fact, we're going to do a lab tonight. Yeah, I got to get another certification. So Mr. Sanders and Miss Bush will be gone on the 13th, 14th, and 15th. So they'll be doing the same thing. I'll be gone on Miss Wilson, but Miss Wilson's not teaching any classes. We'll be gone. We'll leave on the 10th and we'll come back on the 13th. We're going to get certifications in sensors and PLCs. And then Allison and Miss Bush and Mr. Sanders are going to get certification in AC and DC. So we shouldn't have much of a problem, but it's getting that thing you can put on the wall, right? So, and also in a resume. Also, we get points. We got to have so many professional development points every year, and so that would count as professional development points. I've never had problems making mine, so. But a little bit. In PLCs, no. No. How many classes in PLCs do you think I've had? That I've taken? How many do you think? I've had none. So you gotta understand, I came up through the technology. So I was working with PLCs before there was books on PLCs. So yeah. But it just indicates that. Plus, it gives us. I'm not going to get certified. I'm going to get certified to be able to certify you.
Certified.
Yeah. So I'm going to be a certifier. Yeah. So these are what they call train-the-trainer classes. So once we go up there and do it, then we can offer a certificate because it won't do y'all any good.
I did take one of those to certify myself.
We can offer a certification as part of the PLC class, and we could offer a certification as part of the sensors class. But they're all, yeah, because we'll have to look at the sensors class. It's too late for you for the PLC class. But the way these certifications work, they're called NC3, the National Certification Centers.
It's just a test. You have to go through a whole class.
You got to go through a class. It's always part of a class. These are all, NC3 is all hands-on. So, did y'all get the meter certification? So you had to have that 4-hour class before you could even do what?
Well, I imagine somebody technically could, do it.
Well, no, because we have to put you on. It could be done that way, Yeah, but we have to put you up there, and so we're certifying that you took the class before we can
Yeah,
enter
we
you.
all got for PLCs, I mean, certification.
We would have to sit through the
Think
class.
about it, think about it.
Yeah, but if it ever popped up that I allowed somebody to do that, then guess what? Because the way this thing is worked is the certifications are sponsored. So this meter certification is sponsored by what? Snap-on. So to offer the certification, number one, we have to have the PLCs that they certify. It's going, well, no, I think they have. I think the one we're going to is for Allen Bradley, but it's around the RS Logic 5000, not the 500, which is what we were teaching. So that means what we're going to have, and you have to buy the trainers that it's certified under. Does that make sense? Money. Yeah. But I'm gonna stop this. So this class basically deals with something called mechatronics. Anybody know what mechatronics is? Huh? It was for electronic. So basically it originally started off with electronics and mechanics. But what over the time it's actually evolved. So mechatronics is basically just about anything you might run into in an automated system. So mechanical systems, electromechanics, electronic system, control systems, digital control, computers, CAD, just about anything that you would run into in a automated system would be considered to be part of mechatronics. So this is one of the wheels I found up there on the internet looking for mechatronics. Now this is another interesting one. Oops, what happened to it? Oh, this one right here. So just about anything that you could think of in an automated system should be in this list somewhere. Primarily it deals with mechanics, so we'll look at mechanics this time. We'll learn a little bit about gears and stuff like that. PLCs, programmable logic controllers. In this class we don't learn how to program them. In this class we look at them from the output point of view, from the technician's point of view. We're going to be looking at sensors in this class. Let's see, mechanics, sensors, what else? I have to go back and look myself. So this is basic a little history. So it was originated by Mr. Mori. This is a Japanese company, and this company dealt with electronics and mechanics, and he was the first one that come up with this word. So originally that's what mechatronics was. It was a combination of what? Mechanics or mechanical and electronics. But it basically means it's a combination of a lot of mini crafts, right? Or trades. So this is a cleaner one. This is the actual official logo for mechatronics. It says it consists of control systems, consists of computers, digital systems, control electronics, electronic systems, electromechanical, mechanical systems, and CAD. The only thing that we don't do in this class is CAD. You know what CAD is? What is CAD? I don't know what does CAD stand for? What does it stand for? Computer aided. Computer aided design.
3D printers.
Yeah, 3D printers would be part of 3D modeling, which would be a part of designing with computers. So used to, when I was in college, and we took drafting, it was drafting, and it was on what? It was paper and pencil. So I remember when the college got its first CAD computer, where now you do all your drawing where? On a computer. You know, it takes care of a lot of stuff for you. So used to.
It's one of the softwares that they have to do the
Oh,
printers.
up there? Yeah.
Take it, it's like a touch screen. You can scan stuff with it and then have a 3D model and rotate it.
Yeah,
expand it.
we were donated one, but we ain't got it going yet. A little Delta 3D printer over there. Yeah, it's a real neat one. It was given to us, but we don't have the software application to run it yet. So. But it's basically just a mishmash of trades. So this is a pretty good video. Can you hear that okay? I need to turn it up.
Anything mechanical related we get to play with it. Making things run, learning how they run, learning how to make them run.
Every new project is a new challenge.
This is perfect option. I like the fact that you can actually get your hands dirty and work on stuff.
I would like to define mechatronics as a broad combination of electrical engineering, mechanical engineering, controls, and software programming.
Electrical, mechanical, hydraulics, and pneumatics. Includes motors, sensors, electronics, computers. The mechatronics program began because there is such a demand for these high-skilled jobs.
Companies are begging to this school, we need people coming out of this program.
We're going to be picked up like as fast as we come out. There are literally hundreds of thousands of jobs available for those mechatronics.
All manufacturing is mechatronics nowadays.
Robotics, military defense and forensics,
Packaging, manufacturing, pharmaceutical.
shipping and receiving, postal work to automotive,
Mechatronics jobs are actually everywhere in the entire world.
manufacturing skill council certifications, a Siemens certification.
Different schools offer
both of those.
mechanical programs, electrical programs, but this is the only program which combines all the fields.
Most of the jobs I saw that I applied for were asking for not just electrical skills, but pneumatics and PLCs and hydraulics.
This is a very challenging program, but I always tell my students, nothing good comes easy.
It's a challenging field for people, but I think if you have the right skill set. Your favorite part of the program is actually working on the equipment in the lab, setting things up.
Every lab to actually get to work, roll your sleeves up,
Being able to work with your hands and kind of working with those different machines.
Students get exposure to the actual industry level equipment.
DC and AC trainers, mechanical vibration trainers, fluid power trainers, programmable logic controllers, and robotics.
How to set up a belt drive system, how to set up a chain drive system.
The jobs in mechatronics mainly are electrical maintenance technician and mechanical maintenance technician.
They can set up the robots, they can troubleshoot the robots.
Starting salary for a mechatronics career is about $50,000.
It can jump up to 100,000.
I'm very confident with what we're being taught and the ability to take it out into the real world and use it to open doors that were previously closed.
I plan on getting a job in more of automation work,
Like
defense contracting. One day be like Iron Man in the basement.
It's a very, very strong career to get involved in, and will definitely be around for a while.
Companies are going to rely more and more on people with these skill sets because that is where this industry is going.
The skills that I learned here help me tremendously. Great.
If you are looking for a good job and to have a good future, you should join this program, and definitely there is a career there.
So mechatronics is about anything that deals with automated manufacturing. Fluid power is one of them that I left out. So we'll deal with some fluid power, pneumatics in this class. So what we do, what we used to do, they call it the traditional method. So what we would do is we would start with the components. And we would teach how all these components work, all these sensors work, how they work. And then we would move over to the system. The new approach of teaching is we call it the system approach, where we actually start with the what? We start with the system, and then we move to the components. So that's why when we take this class, all our components, we're not going to really understand. We don't need to understand how they do what they do. What we need to know is what they do, right? And if they don't do what they do, then used to, when I first got into the trade, we fixed everything. We fixed everything to the component level. But that's back when you bought the first IBM computer running an 8086 processor, 8088 processor, in fact. Only had 64K of memory in it. Used floppy disks. Had a 10 megabyte disk drive. That computer cost $2,000 off the shelf. And it was the cheapest computer out there.
10 megabytes.
No, 64 kilobytes. A 10 megabyte hard disk drive was in it. And then it had a 5 1/4 inch floppy disk. $2,000 was and a monochrome monitor. Green on black. $2,000. So when those suckers broke, we did what? We fixed them. We used to teach a component level troubleshooting class for an IBM compatible computer, where the students could actually figure out which IC was happening. But what's happened over time, especially with integrated circuits, so you got a circuit. So we started out, I wish I could find my motherboard with all these integrated circuits on it, because everything was done individually, right? But you got something that does the same thing all the time. Then what eventually the engineers will do is they'll start integrating into a single package. So if you popped up your cell phone right now and looked at the processor, it's probably just one big chip in there that does what? That does everything. When the cell phones first came out, I don't know, we call them bricks. Y'all ever seen those things? They were this big and had an antenna on them that long, because they were still using a lot of discrete or individual components. So the more integration that you put into a system, the harder it is to fix a device. But also what's happening is the cost drops down so much. So now we don't fix sensors when they break. We do what? We replace them. So we don't really know, on a troubleshooting point of view anymore, we don't really need to know how these sensors work. We just need to know this sensor detects metal. This sensor looks for light. This sensor will pick up anything, right? You understand? If we understand that, then we have a good idea of what's going on. Now, of course, you still need to take PLC courses and stuff like that, because from a technician's point of view, everything is programmable. With the PLCs, you're the one that programs those. So these guys right here, most people that we know don't program them, right? What do? Or your cell phones. How many of y'all? They do teach a class here, by the way, on how to make cell phone amps. You know that, right? So, but most people don't even do that. When I first got into computers, the language was a binary language. We called it machine language, which is ones and zeros. So we had to write programs using ones and zeros. Now we have programs that write the machine language programs for us. So the computer still only speaks what we call a machine language, and it's a binary language of ones and zeros. But now what we do is we buy an application that lets me write programs, and then when I save it, it saves it in what? Machine language. So it makes it a lot easier for us to write these things now. But what we're going to do tonight is we're actually going to go over to the system, and we're going to see what both of our manufacturing lines do. And we'll talk about a little bit of what's going on, and then, of course, we'll learn more and more about the different components about the manufacturing lines when we come into. And what's nice about this, so this is the Siemens approach. This is what Siemens calls the system of approach. So the first thing we do in these classes is start off with the what? The system. We start off with the system. And then we'll look at the different modules that make up the system. And then we'll start looking at the components on what they do. And then we'll look at physical. And then over here is when we actually start doing what? That's when we actually break it and start putting problems in it. So what you'll find out as a technician is that you can't fix something if you don't know how it works in the first place, right? So we'll learn different techniques that Siemens uses as far as figuring out the sequence of events that a manufacturing line will go through. So every manufacturing line is usually subdivided into, over here we call them modules. But even in Mercedes, they have certain sections that do certain things, and we just pass that vehicle between the different sections, right? You understand that? So we basically do the same thing here, but over on lines we refer to them as modules. So we got this module that does this, and this module that does that. And we'll start off looking at individual modules. We'll figure out how they work, what they do, the sequence they go through. If you understand the sequence, if it breaks, if it stops working, you say, well, how far did it get in the sequence? And what's required to get it into that next step, right? Does that make sense? So this is what, this is Siemens. Siemens calls it the system approach, which most people basically do this anyway. It's just that was the first one to put it on paper. So this is the basic makeup of our system. We're going to look at electrical, fluid power. What's a fluid, by the way? What's a fluid? Hydraulic is a fluid, but a fluid, yeah, anything that doesn't have a fixed shape and takes the shape of whatever it's in is considered to be a fluid. For years, I thought fluids were liquids, but they're not. So any air. So we're sitting here in a fluid right now, right? Because air does what? And it easily moves. So the fluid power that we're going to deal with in this class is, we do have a hydraulic pump back there, but it started leaking, guys, so we can't use it. And we're going to look at mechanics and then, of course, control. But the PLCs we're going to look at is not from a programming point of view, from what the PLC does in this class. And of course, you'll take classes in PLCs, and we actually offer 3 different levels of classes. I think they put Tucker and y'all put both the 2 classes, and then we offer PLC 3. During the PLC 3 class is when we actually convert the Festo line from Allen Bradley's over to Siemens PLCs. And I think Rosa wants y'all to take that class. They added that to y'all's plan. So y'all will be taking that class instead of taking, because they dropped the RDG 114, the critical reading. They dropped that from the degree, so that gave y'all 3 more hours. So they're going to let y'all take that class. So this is basically the course outline. Of course, we're going to start with the system tonight. We're going to go over to the system. We're going to see what they do. We're going to let it run through its cycle, go all the way from the start to the finish. Then we'll do both systems. We'll look at what the Festo line does and also the Amatro line does. The Festo line right now is not really designed to be tore apart. The Amatro line is, so our labs will be on the Amatro line. But we'll start off with safety. We'll look at the system. We're going to skip over. We're going to go over to the system tonight because the first lecture that we'll do online will be the safety. We'll look at the OSHA 1910 safety standards, and then also we'll look at lockout, tagout procedures. So we're going to lock out, tag out in this class. We called it a review, but we're going to actually learn enough about electrical. Most of y'all know, y'all all had DC at least, right? Everybody's had DC. Some of y'all had AC yet, so go enjoy that class. You getting there yet? That's one of the harder courses that we teach here. Fluid power, mechanics, PLCs, and then of course we'll look at the documents. Being able to read the documents that hopefully are provided with the manufacturing line, and I'm sure that a company like Mercedes, that was part of the bid process at U.S. Steel. If they bought something, they had to provide what? All the documents and everything that went with the item that they bought, including all the schematics. Electrical flower. We're actually let y'all play around with some solving, and then a little